The universe is a vast and mysterious place. Whether you're talking about the mysterious stars or the beautiful planets, it seems like there's always something new being discovered. And one of these discoveries in particular interests me the most. Black holes. Now see, we've all heard of black holes one way or another, either like in 8th grade in your science class or maybe in the media somewhere, but not many of us know just how complex and interesting black holes truly are. You see, many people just assume that black holes are really just cosmic devourers that destroy anything in their path. Today, through this speech, I'll clarify the true nature of black holes. I've long had an interest in astronomy and have therefore done extensive research and used many unbiased, credible sources for this speech. If I want you to take one point from this, I want it to be that black holes are truly interesting and truly complex. Throughout this speech, I'll be covering how black holes function in their basics, how black holes are formed, and then some other interesting facts and misconceptions about black holes. So first, let's talk about the basics of black holes. What are they? Essentially, black holes are areas of condensed mass that is condensed so hard that out of all the forces, gravity is created the most. According to the webpage titled Black Holes by Louise Lerner at the University of Chicago, accessed in 2024, black holes are regions of space with mass so condensed that gravity overwhelms all forces. And you see, because of this, we actually observe actual stars orbiting black holes because of how powerful their gravity is. You see, black holes have this section in them known as the event horizon. And you can think of this point as kind of the area of no return, where any object that goes near it is sucked in because the gravity at that point is so strong that not even light itself can escape its pull. And now, to scientists, it's actually unknown what is truly inside a black hole, but we do know that black holes are composed of two main parts: the event horizon, as I previously mentioned, and then the singularity, which is the center middlemost point of the black hole. Now, due to our current gravitational theories and understandings, we really don't know how the singularity functions. We just know it's there. Now, there are two sizes of black holes. There's star-sized black holes, which are about the size of an average star like the sun, and then there's supermassive black holes. And supermassive black holes are on a completely another level. You see, supermassive black holes can be millions or even billions of times the mass of the sun. And these types of black holes are typically found at the center of different galaxies. And our galaxy actually has one. It's called Sagittarius A, and it is approximately the mass of 4 million suns. So now that we know the basics of black holes and how they function, let's look at how they form. According to the webpage titled Black Holes by an author at the National Radio Observatory, accessed in 2024, a black hole is actually the superdense remains of a very big star that imploded, violently collapsing in on itself during a supernova. So a supernova is essentially when a star reaches the end of its lifetime and it implodes and collapses in on itself, condensing so much mass in all its atoms, and its atoms get collided and break apart, and it releases a whole lot of energy out into space. And this energy is used as a mainframe for other stars and planets, and etc. And after this supernova process occurs, if the star is big enough, it'll leave a black hole in its place due to all the condensation. So now that we know how they form, let's talk about some facts and interesting misconceptions. Now, I think the most common misconception about black holes is that they're just cosmic beasts that devour everything. But that's really not true. According to the webpage titled Black Hole Basics, edited by SMD content editors, provided by NASA, accessed in 2024, it stated that black holes are not just cosmic vacuum cleaners, and that from far away, their gravitational effects are just like those of other objects with the same mass. So think of it this way. If our sun was replaced right now with a black hole with exactly the same mass, nothing would happen. We would still just orbit it like we do every day. Now, of course, it would get very cold and very dark, but we wouldn't get sucked in. Now, I want to talk about a term known as spaghettification. And yes, that is a real term used in science. When an object approaches the event horizon of a black hole, it essentially gets thinned out and stretched so much that it literally looks like a spaghetti noodle. So now, black holes don't actually emit any of their own visible light, but if they're big enough, they do have things known as accretion disks. And these accretion disks basically are areas of big gas and dust that spin around black holes. Now, as I mentioned before, black holes come in many different shapes and sizes. And the largest known black hole we found is 66 billion times the sun's mass. And these types of black holes, very large black holes, can accelerate particles to near light speed. So you may be wondering, if we can't see black holes, how do we detect them? Now, as I mentioned before, a black hole itself may not emit light, but its accretion disk might. And with the right technology, we can actually view these accretion disks. And then, if there is no accretion disk, we can also observe the gravitational effects they have on other surrounding stars. In summary, we now see just how truly interesting black holes really are. Throughout this speech, I hope that you understood the basics of black holes and how they function, how black holes form, and then I hope you enjoyed the interesting facts I provided you. You see, science is ever changing, and throughout history, we made more and more discoveries every day. And while we may not know as much as we want to now, hopefully future generations will be encouraged to learn more and propel us even further into science.